Hey guys, it's Cami. Don't miss great tech stories from our guests and our hosts, Jackie the Monk and Walter Del Barre, only here at Mangtas Nation.
Welcome to Mangtas Nation Season 2. This season is all about tech of the future. We'll be sharing real world experiences and featuring astounding guests to help guide you in your tech journey. Are you ready?
I'm ready.
I'm ready.
I'm ready.
I'm ready.
The show starts right now. Hello, everyone. Here's for another day of unearthing remarkable and inspiring tech stories at Mangtas Nation. Now, our guest for today is a managing partner at Ardan Studios, a web app development company. And he also co-authored the book Go in Action, and he is the author of a blog at goinggo.net and an organizer for Go and MongoDB meetups in Miami, Florida. Now, our guest is focused on Go education in his new venture, Going Go Training, to help individuals and groups take their Go knowledge and coding skills to the next level. Without further ado, listeners, please help us welcome today's guest, William Bill Kennedy.
Wow, you said all that with like one breath. That was super impressive. Yes, nice.
I practiced, Bill. welcome, welcome to the show again, Bill.
Thank you for having me.
Well, yeah, thank you for being a guest on our show. We're so honored to have you here and excited to talk with you about what you've created and done so far. So, well, I'll give the floor to you, Bill, so you can start off by telling us and our listeners a little bit about yourself.
Wow, I'm like 52 years old. There's a lot to say there. No, so a little bit about myself. For the last 10 years, 2013, I've been primarily focused on the Go programming language as a software developer, working on projects and training developers all over the world in this programming language. In fact, before COVID, the joke used to be, "Where is Bill on the planet today?" And I would, even on my Twitter, have to just say what GMT I was in, right? I would need that myself. I learned how time is complicated, right? Like I started living in GMT basically for like 2 or 3 years, bouncing around the planet. It was fun. It was kind of sad when it all ended, February in 2020. And now that I've been home for the last 2 years, I kind of like it. Like, I guess you get used to routines and patterns. So I had a routine where I was on a plane every week. Now I'm on a routine where I get to kind of stay home. And I do recordings in a studio that we have here in Miami. But yeah, so I really enjoy the training side of things, and I love teaching, and I love learning, and then sharing what I'm learning. And my primary focus this year has been really building out some very advanced Go material around blockchain. Not to build apps on the blockchain really right now and smart, none of that. It's like I'm literally trying to write a blockchain in Go, a small implementation, just so I can learn the tech. So I've got this mix of like a Bitcoin and Ethereum sort of implementation, and that's been a lot of fun. It's even helped strengthen some of my Go skills. So it's kind of what I'm doing now. And I've really been a software developer professionally since 1991. So I'm tired. I always say, I'm tired. I'm tired. You're young. I'm tired. Right?
And were you always interested in tech or software, Bill?
Yeah, when I wasn't a good student at all in school. In fact, the number 7, I have 7 kids, so I just number them. So number 7, he's like 10. She gets straight A's. Straight A's. Every, bop, 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 bop. So I can't compete with that because I was like a C student, and I only even got C's because, we're talking like the 70s and 80s. I would have gotten beat if I came home with anything less than a C. So there's some motivation there, right? But I couldn't get A's. So I was going through some paperwork about a month ago, and I found these old report cards from elementary school. And one of them was an award I got for perfect attendance. So I told the 10-year-old, I said, look, anybody can get straight A's, but how many people can get perfect attendance, right? I mean, that's a commitment to school, right? So that's kind of like our little thing here where She's like, no, anybody can get perfect attendance, but I'm like, So that was my schooling, right? It was like C's. I only had perfect attendance because I lived right behind the school. My mom would make sure I was out of the house. Um, but somehow in junior high school, I got my hands on my first computer and I just kind of fell in love with it and just started with basic programming and kind of knew that I was going to go to university for that. And I'm so glad I found that, right? Because how many kids, I got two boys out of the seven, two of them are boys. They're 18 and 19, and they just haven't found what they want to do yet. And and that's okay, right? Like they haven't found
Mm.
their passion yet. But I had found my
No pressure.
passion. No, no, they know that. Like, and every one of my kids, at least the first three now who have graduated university, they took a year off after school, and they're all finding their way now, right? And I'm okay with that, right? Just I'm always about just be productive and move forward, and I'm good with it. I'll support you. But I found my passion in like eighth grade, and I'm still passionate about it. I don't know what would have happened if I didn't, because that passion allowed me to kind of stay out of trouble. If you do this, you're not going to be able to do that. And I really want to do that, And I think for teenagers, and I've seen it at least in my boys, right? They've gotten into a bit of a mess since COVID started. And they just didn't have anything to tie them down where the consequence of this particular action would have kept them from doing it because they have a passion to move in this direction. So I think without that, you really get lost, and your decision making can sometimes be faulty. And you have a lot of kids right now because of COVID and lockdown, losing friends and losing activities and losing a part of their life, and they've lost a bit of that ground. I've experienced it. It is hard to parent teenagers right now. I can just tell you that it's a nightmare. So I kind of always had this passion. I still do. I joke a little bit that I'm tired, but I am a little tired. I'm excited about the blockchain stuff that I'm working on in terms of trying to build one from scratch. Every year now I try to focus. Last year it was GraphQL. Said I really want to learn GraphQL and how that tech works, and I did that. I don't know what I'll do next year. And I think that's important too, right? That you're constantly working on stuff that you're excited about, and then have the ability to look. I've met people who love to just fix bugs, and every organization needs that person. They don't want to build anything new. They don't want to. They love going into a code base, and like I'm not passionate about that, but I love when I meet people who are, because that's an important role, right? So it's not a what I don't want people to hear is, oh, if you're not doing something new every year, you're not improving, or you're like, no, absolutely not. What I want you to do is find that thing you're passionate about and keep doing it until you're not passionate about it anymore. And then find something new.
And so, Bill, what is it exactly you're passionate about when it comes to tech and programming? Is it building stuff?
It's learning. It's the building allows you to learn, but it's gaining. I'm the kind of person that wants to know 80% of one thing. My business partner, Ed, is somebody who loves to know like 20 to 25% of everything. That's not me. And again, I'm drawing really thick lines, but I've met people like this. Do you want to know 30% of everything, or do you want to know like 70 to 80%? I'm on the 70 to 80% side, which is why I dig really deep. So I love being able to have a strong semantic. I don't have to have a full implementation knowledge of something, but a full semantic understanding of how things behave with some ability to implement parts of it, which is what I'm doing. So I can walk in the room, and if we're having a conversation about this thing, I can have the conversation with you. I'll give you, again, I keep going back to blockchain because that's kind of what I'm working on right now. But you walk into a room with people that are all over blockchain, and you ask them how it works, and nobody has a clue really how it works, right? They're all throwing money at it, and they're doing this and they're doing that. And maybe there's somebody in the room that's writing a smart contract for something. But you ask them the core tech, how does it work? Where's the complexity here, there, blah, blah. Nobody knows what's going on. That scares me, right? I don't want to be building on something that I don't really have a good foundation for. That's me, right? There are others who don't care. They want to build something, get it working, get it out there, and that's beautiful, right? I mean, probably as a product company, there's some level of that you need. That's not me. So I'm passionate about being able to learn something I didn't know last week and feel fundamentally solid enough where I can teach it. And teaching is really the passion for me. So once you can teach something, you really know it, right? So I'll write a blog post about something first. That usually requires even code changes. Then I'll try to talk about it. And at some point, after doing it like writing and saying it like 10 times, you finally get it, right? But if people come to my classes, unless I tell you this is the second time I'm teaching it, right? People are like, Bill, how did you do that off the top of your head? I like, because this is all I've been kind of talking about for the last 2 years. In fact, my brain is full other than this. Ask me another question and I'm going to fall down. But this stuff is locked in right into my head, so I can go to a conference and just jump on stage and start talking about these things. Why? Because I've been talking about it for the last, I'm passionate about it and I've got it locked in. So that's what's exciting, right? Now, I'm going to tell you this. Every time I got to start something new, I do get like depressed, like this idea that I have to start, like I know nothing and I want to know everything. This is depressing. Where do I start? And that's when I got to pull back and go baby steps, baby steps, baby steps. And I promise you, Bill, in 4 or 5 months, you're going to know so much. You're going to be like, oh my God. And it's kind of where I am now. But I'll tell you, I'm always depressed that very first kind of moment where I'm like, I know nothing here. I'm going to struggle. I'm going to feel like an idiot for the next like 4 weeks. And I hate feeling like an idiot, but you got to fight through it because nobody is born with the knowledge and experience they have. Like, I don't care if whoever you look up to at the end of the day, right? In tech, you look at somebody like, wow, they know so much. They're so smart. Well, they weren't born with that. They had to learn it just like you will have to learn it. So you have to kind of remember that.
And I think you look at, like when you start, you see the mountain in front of you. And then when you just start hiking and training, you just take the first steps and then you kind of don't see the mountain anymore, but you just see the path ahead of you and you just want to.
Yeah, but sometimes the mountain gets larger as you're climbing, right? Ignorance is bliss sometimes. But it's about, and I say this in all my class, it's baby steps. Like I think I'm going to just talk about programmers and engineers for a sec. I think what a lot of programmers and engineers lack is not the ability to write code. It's the ability to break a problem down. And I'm not talking about an issue in GitHub. I'm talking about you have a problem in front of you. What are the walls that you need to knock down first before you can even think about actually solving it? Like, how do you break that problem down into chunks that you can have success around and then kind of integrate all of that together? That I'm really good at. That is something I've learned. I'm really good at that. And I try to teach that as well. And if you're not somebody who's good at, you get overwhelmed easily when somebody throws a big problem at you. Like, find the people around you that are good at breaking it down and learn from them how to break it down. I think that's one of the most important skills any engineer can have, to not get overwhelmed, break that problem down into reasonable baby steps, and then just start knocking those out. And just like you said, eventually you'll be like, oh my God, look where I'm at. Look how far I've come.
You talk about training and teaching, Bill, but I don't think we've touched up on that yet. Can you please tell our listeners, like, what type of training do you do and where do you do it?
Type of training. So I've focused on trying to make software developers, my classes are Go classes, right? So I'm teaching the Go programming language. I teach at what I call a micro level, where I'm teaching you down to lines of code and how to think about the language. A lot of design philosophy, a lot of guidelines around that. And then I have a macro level class, which is architecture and building product. But what I like to think is that it's an engineering class where we're using Go, much more than it's a Go class trying to teach at And I think that's more important. I think what I try to do is really um, lay down a foundation of material to make you think about what you're doing down at a line of code in a higher level. So why did you do that? What is the design philosophy behind that decision? Because the big thing, and we've lost this, my kids have lost this, right? There is no decision that is free. Nothing is free. Every decision you make in life and in engineering comes with a cost. So if you don't understand the cost, you're not engineering. I'm sorry. Now, some costs are so minimal that we don't think about them, but there's always a handful of very large costs. And so engineering isn't about right or wrong, right? It's about, I'm not willing to take that cost for this particular benefit because I think that's going to hurt us maybe in the end, or it's going to hurt us in the short term. Like those are the engineering conversations. And I try to teach people to understand that readability is about not hiding the cost of the code you're writing. Readability is literally that. It's about not hiding the cost and making sure you're writing code where the average developer on your team can maintain and comprehend what you're doing. And then everybody says, well, that means you have to make code simple. I go, whoa, 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 whoa. Actually, simplicity is fighting readability because simplicity is about hiding complexity. And the moment you try to hide complexity and you lose the ability for me to read it and understand the cost, because it's easy to simplify something and then suddenly hide the cost of what you're doing. The moment you do that, then that simplicity is no longer really adding value, right? You're actually making it harder for me. Simplicity is one of the most complicated things to apply to any sort of kind of software you're writing. To me, it's always like a third or fourth refactoring of the code. The first thing you need to do is be a programmer, right? And I try to teach this too. I need you to be a programmer first, not an engineer. So what do you mean? You're wearing two hats. Programming is about you just trying to get something to work. You're looking for code. You're trying to knock that wall down. You just want something to work. You don't care about idioms, guidelines, design philosophies. Throw all that out. Because if you don't have a piece of code that works, we can't even move forward, right? That's programming. The problem that I see is that people stop at programming. They don't now do the engineering side of it, which is a whole bunch of refactoring of that programming to make sure you can maintain, manage, and debug the software you're about to put in production. And engineering is about understanding the cost. It's refactoring that. It's maybe at some point trying to simplify through abstractions, the right ones, without losing the ability to read or understand the cost. This stuff doesn't happen overnight. Here's one of my favorite things I start every class off with. I say, okay, we've been talking for 20 minutes. So if I ask all of you to write a blog post in the next 20 minutes about everything that we've just talked about, you got 20 minutes to write a blog post. And if you actually attempt to do it and you hand me this blog post, you know what each and every one of you are going to say to me? Bill, look, man, you only gave me 20 minutes to write this. So you know it's not very good. So Bill, when you read this, please take into account that I could not have written the most amazing blog post in 20 minutes. And I say, you're all going to say this because you want to protect yourself from my wrath, right? But think about this. How many of you feel like every time you put your hands on the keyboard to write code, you have to be perfect? You have to be perfect in that moment all the time. But writing code is no different than writing a blog post. You got to think about it in drafts. You're going to write that first draft of code. It's not going to be perfect. It's not going to be beautiful. It might even work. That might be your programming. But until you review it and refine it, until your teammates review it and refine it, until that goes through the same review process that your blog post does, you cannot publish it. It can't go into production. So I'm giving you permission to no longer be perfect. Work in stages until at some point it's good enough, because it's never going to be perfect anyway. It's good enough. And then we move on, right? And these engineering ideas have been completely, when I tell people that I'll spend maybe an hour writing code and the rest of the day refactoring it, they'll be like, Bill, I don't have time for that. I'm like, you don't have time not to do that. Because the moment you stop refactoring that code to make sure your mental models are in place, it becomes a legacy horror at the end of the day, right? So like, there's a great quote, right? That I can't remember who said it, but basically it said that the downfall of civilization is going to be legacy software, right? Like in fact, I want Hollywood, the next Hollywood movie shouldn't be about asteroids and earthquakes. No. It should be about all the legacy software we have right now, running power grids and banks and everything, shutting down on the same day. You want to talk about a disaster movie? There it is, right there, right? Because we know that almost everything is running on Band-Aids and bubblegum. There's somebody right now running down the hallway at Facebook, Google, Apple, and Microsoft. There's somebody right now, this second, running down the hallway because something's down. Now, because the systems are so big, your email isn't down, but there is somebody's email that's not working right now. It's just not possible, right? So these companies creating the illusion that everything's working because they've learned how to distribute this and do this at scale. But I promise you, somebody can't get email right now over a Gmail. Something's not working, right? And so it kind of comes back to, all these ideas, where you can't be perfect. You need a whole bunch of eyes on things, and you got to learn how to refactor and know what you're refactoring at that moment in time. And then not beat yourself up when you look at the code in 3 days and go, what drugs were I on 3 days ago when I wrote this? Because maybe you were in your programming mode and you got distracted and then you came back to it. So can't beat yourself up over any of that either.
Clearly, very fascinating engineering principles, and I'd love to be a student of you someday, Bill, and learn from you. But the main question I have is, right, why Go? Because you're primarily engineering and then applying it to Go. Why Go of all languages?
I can only tell you why Go for me. I started as a C developer professionally, coming out of university. We're talking
because you were
like
a C student.
There was a lot of Pascal and C. Yeah, I was a C student, exactly. Actually, that's pretty funny, Jackie. I like that. I was a C student, so I used to C programming. Like, oh, that's brilliant. I'm going to use that. So I did 10 years of that, right? And I did 10 years of that on Microsoft operating systems. I did a lot of multi-threaded software development in C. When C# came out around 2001, I jumped on that bandwagon. But there was one thing I hated about C#, and I loved the language. I was very productive. And it's not a fault of the language itself, but I don't like object-oriented programming. I never liked this idea that everything had to be a type where behavior was attached to types, and then you had to construct an object in order to execute any behavior. It all seemed like extra ceremony. Now, if I wanted to do something, I had to construct something, I had to figure out where to keep it, and then I can now call behavior. If you had seen my C# code, it was all static classes and static functions. I got my functions back by just using a class as a namespace. So in about April 2013, I have this company here that I'm now with, Ardan Labs. We're doing contract work on the Microsoft side of projects. This is what we knew. My business partner and I did 20 years of building stuff on Microsoft. Azure was just kind of coming out, right? So you were still managing your own systems, your own data centers, everything. So there's a project in the city of Miami Beach, and they're taking bids. So we were like, let's bid on this project. And after we did all the bid work, because you got to tell them pricing on everything, right? From licenses to machines. I realized that Microsoft was going to make more money than we were on this project. And I looked at my business partner and I said, dude, we are never going to survive in this business if we have to constantly charge customers all this pricing in terms of licenses, right? And it was going to cost us $3,000 for every developer that came into the shop because you have to buy the licenses. I said, we're dead. I said, it's not going to happen. My business partner at the time was already looking at Ruby. And I said, we got to get on Linux because we're not going to survive. So I started looking at programming languages to move off of C# into Linux. At the time, Mono, I think what it's called, didn't really exist yet to run C# on Linux boxes. It wasn't there yet. So that wasn't really an option. So I looked at Ruby. I didn't like it. Interpreted language. I'd always had a compiler behind me. I said no. I looked at Python. Didn't feel right. I looked at Erlang. Didn't feel right. Just didn't, for whatever reason, none of these languages felt right. So I went back to my business partner. I said, I guess we're going to keep building stuff in C# or something. We'll do all the front end work maybe on Linux, but none of these languages resonate with me, and I ain't writing C code again. Those days are over, okay? I'm now a B student, Jackie, so no more C. My business partner at the time says, Bill, there's one more programming language I want you to look at. It's called Go. And I'm already like exhausted. I'm like depressed already, right? And he said, no, Bill, just look, just over the weekend, take a look at it. So I downloaded it. I started taking a look at it, and every light bulb in my head went off. This was like being able to get back to my C programming roots, my Pascal and C programming roots, without all the object-oriented programming from C# and without all the extra complexity that comes with C. Right? In terms of both syntax and just all the work you have to do around memory management and all that kind of stuff. It was like if I could have dreamt up a programming language for Bill, Go was like, it was it. And then that weekend, I just started like diving deep into it. Now, what's interesting here was when I first started in C#, I had started a business, and I wanted to kind of write about my experience learning C#, but my business partners at the time were very about, and this is a Miami thing for some reason, especially back, we're talking like 2004. It was, no, don't share anything with anybody. We're in business. Why would you do that? And so my business partners didn't, crazy, right? I fought with them, but they're my business partners. They didn't let me really share the code I was writing at the time in 2004 and anything. So when I switched to Go, now I'm in my next business, I tell my business partner, I'm going to start blogging about everything, because not only was I learning a new programming language, I knew nothing about Mac OS or Linux. I was learning an operating system. At the same time, I'm learning, and I already told you, I get depressed when I have to start over. I had 20 plus years of experience. I could told you the Windows internals inside and out with my eyes closed. And now I am a newbie again. I mean, I can't even set an environment variable in my shell at this point because I don't even know what that means, okay? So I'm fighting so much here. So I tell my business partner, I'm going to start blogging now, everything I'm doing, as from the point of a newbie. Because how many times in your life are you this much of a newbie? And what was I, like 40 years old, right? Like, how many times in your life are you this much of a newbie at like 40? I mean, total newbie. So he said no, and I said, you know what? No, I'm doing it. So I started blogging all the way from like from what I would now consider basic operating system stuff that I didn't know to really basic understandings of the Go programming. I just started blogging everything. And it resonated with a lot of people because these were anything advanced in terms of, it assumed that you knew nothing because I knew nothing. And that's who I was writing it for, right? Everybody, now today, after like 10 years, right, and 100 and something blog posts, I still try. It's really hard sometimes when you know things to stop telling yourself, oh, everybody knows that. No, Bill, not everybody. No, everybody knows that. What I can do is say, I've written about it before, so I'm going to at least assume that if you've been following me, I've told you this. But it's really hard when you're putting material together, when you're writing something when I wrote the first book, they were like, you need the MRQ, the most, or MV, whatever, the most viable reader. Like, who's your MQR, minimal qualified reader. That's what it is. They would say, who's your minimal qualified reader? I'm like, oh, yeah. Because when people wanted to review the stuff, if they didn't know who I was targeting, they couldn't know how to review it, right? And so all the way today now, it's all about this. Who's the minimal qualified viewer? Who's the minimal qualified reader? Who am I targeting? And I don't do a lot of introduction in my classes only because there's so much material to get to. And I do more lecture, coding, pair programming kind of stuff in class. But I always try to at least set the stage on who I'm expecting to be in the classroom. And if you're not this person and you're struggling, you probably should be struggling. And I try to help you, but if it's not working, I give you money. I give money back to anybody. Bill, this is not working for me. No problem. Come back when you're ready, or do this or that. It's like, so I try to set that stage early on. I think everybody needs to.
And you touched upon your book, and we would like to ask you some questions about that in a sec. But before you do, you started off the conversation that with saying that you're building a blockchain on Go, right? Is this merely your curiosity, or are you going to solve a problem that's out there?
This is not a production code base. This is for anybody. I call this is an advanced Go class because this stuff is super complex. It's a reference implementation of a blockchain that should never ever be used. In fact, I'm doing some things to make sure that nobody ever runs it in production. Okay. It's taking the less complexities of both Ethereum and the Bitcoin blockchains, right? I'm studying these two blockchains, and whichever one is less complex in a certain area, that's what I'm trying to implement. So it's truly this blend, right? Which I think is good for class because then you can say, look, this is what Bitcoin's doing, this is what Ethereum's doing, this is what we're doing. And then what it does is it essentially gives you I think, a pretty strong semantic understanding of how these blockchains are working underneath. And then also you can then extend to, look, and this isn't even production. Imagine if you really wanted this at a high scale production, you can start to, as an engineer, imagine that extra level of complexity that I have no intent to ever try to implement because it's not necessary, right? But just by basically building my own little wallet and signing a transaction and sending it to a node and doing some proof of work mining against 3 nodes at the same time, and then being able to validate that a transaction is sitting in this block, just that stuff alone, which has taken me 5 months to build, right? You start to really appreciate and understand at least how the tech works. You appreciate the complexity of it. You appreciate how those systems are even just running day in and day out. And that's all I wanted. There are a lot of people in tech today who are very anti-blockchain, and I get it, okay? Everything right now is speculation. Everything right now is just speculation. It's a lot of fraud going on, and there's a lot of bad things happening, right? Like, so I get it. But I've met too many people that were complaining and talking negative about blockchain who really didn't understand how it worked. And I didn't want to be that person. Okay, it's not like I have a wallet. It's got God knows how many .000s in front of it in terms of ETH I own. I'm not buying Bitcoin. I'm not buying ETH. I'm not building a DAO. I'm not doing NFTs. That's not my goal. My goal is if I'm going to say anything negative about the blockchain, it's going to come from a technical perspective because I know. I don't want to just be regurgitating what I heard somebody else say. And that was the big thing for me. I really wanted to dive deep into the tech. So if I did decide that I wanted to build something on it, 2 things. 1, I know how the foundation works. And then two, I really want to make sure that if I do anything on the blockchain, it's being done in an ethical and moral way. That is critically important to me. If some company comes to me and says, Bill, we want to build this on the blockchain, and it even smells at all like a Ponzi scheme, I'm going to go, I'm the wrong person. I'm the wrong person. And I've talked to investors and I've talked to people. And the moment they don't particularly care about the person on the system, I'm gone. This is not what it's about. I think there's some real valuable things that can be done on the blockchain. I just think it's beta software right now with no guardrails or security for the average person. And I don't know. I think there's a lot of work that has to be done. I don't want that work to stop. What I would like the world to do is tell everybody, I say I've aged out. This is what I say. I'm 52 years old. I've aged out. I cannot risk any sort of money I have losing it tomorrow in the blockchain. I just can't. So I would like the world and people in the blockchain world to turn around and say, look, if you're like 25 and you got $20,000 you don't care about, go have fun. I'd rather go to Vegas, but go have fun right now, today. And I appreciate all of that because it's allowing the engineering to continue. Maybe 10 years from now, these blockchain systems are going to be so solid with the right safeguards and the right things in place that all this fraud and all this stuff and the regulation comes in, it's going to be gone. And it's going to be beautiful. I think you're about 10 years away. So I don't want to shut it down. I don't want to shut it down. I just want the world to appreciate where the tech is right now, and what you can and can't do on it. So I'll give you an example, right? I read something yesterday where this person was complaining because this burger joint suddenly started taking crypto. So this person walks in, buys a hamburger for their crypto, whatever the amount of crypto it was, right? Let's just say it was one coin. That moment when they bought the hamburger, that coin was worth $12, right? A month later, that coin now is worth $100 on this open market. And they're beating themselves up for buying a hamburger a month ago with their coin because they just ate $100 worth of hamburgers, right? And my brain says, whoa, right? Suddenly this person realizes that this isn't a coin for buying things, it's a coin for investing. Because if you buy something and the price of the coin goes, this doesn't happen with fiat currency, right? Like I bought a hamburger a month ago for $3. The hamburger is still $3 today, and that $3 is still worth $3 today. It doesn't happen. And so I don't think also the blockchain is going to become a pure e-commerce system until that coin is the same a month from now. I don't know how we get there. I don't know enough about finance. I'm going to try to guess. But I think that also has to happen at some point, where there has to be a stabilization of the currency.
So you mentioned stabilization, safeguarding, regulation. So I guess in 5 months you learned quite a bit, right? And I guess, how about if you were to name one positive, the main positive in your view on blockchain for the future of the world? What would that be in your opinion?
I think it's going to be an amazing side database for systems that deal with anything related to auditing. Anything that is truly safe to be written once and never have to be deleted ever again. So contracts, there's a lot of government kind of contracts, there's private contracts. I think you can build solutions where you say, you know what, this particular piece of data, we're going to put it on the blockchain so it's made available publicly where anybody using any client they want can see that it's there. That should not be pictures, right? It should not be anything that we might conceivably not want to exist. But I think in terms of auditing, contracts, these types of, or an example could be an asset. Maybe you have a public asset that you want to imagine cups. These are really special cups, and there's a finite number of them in the world, and you want to be able to track from manufacturing to who has it, who has this cup, right? And you want to really make that open. Your job is to be completely transparent about this cup. I think the blockchain database serves an amazing purpose to be able to list that cup in the open. You still need your own private databases, I think, to manage maybe whatever your site. I don't think that's decentralized. That's beautiful. I still think you're going to be building a lot of centralized web apps and mobile apps and sites. But I think that the moment you say, I think this should be truly transparent, this asset should be truly transparent, this contract, I think you can use it as that side database to say, okay, look, I'm not hiding anything from you. It's right there. We just have to be, as a society, super careful what we're putting on that blockchain, right? Like, I've told my kids forever, right? Like on all of their apps, I go, why are you loading all these pictures? Oh, Dad, they're private. No, nothing's private. No, Dad, nobody else can see it. Nothing's private. Even if that company gets hacked tomorrow and they leak every picture on a public drive, what are you going to do? Well, yeah, now their safeguard is eventually maybe the government can come in and force them to delete everything. Doesn't mean it's not going to be saved locally somewhere, but you still have the potential of somebody coming in and saying, you have to delete that. And it could get done. Can't get done on the blockchain. There's no regulation the government can come in and say, you got to remove that picture off that transaction in that block. I'm sorry, it doesn't work that way. It's a cryptographic, right, audited database. It's not possible. So I just think that we have to be really, really smart about what we're putting there. Just like I think everybody has to be really smart about every picture they post. But I think there's some benefits. I think there's some really interesting benefits there. We're just not there yet, and I don't see the projects that are thinking about blockchain in that way. Right? There's so much money in it right now, right? That if you just say we're going to use the blockchain, it's almost like, here's some money, take, right? And I just wonder how many of these companies know, like, okay, I'm going to raise $10 million, and I don't care what happens in 12 months, right? I've done it. I need to be more on that. I got to sleep at night, and I got to look in the mirror every day. So, but I think the tech should be worked on. I think it should be improved. I think there's got to be, I have no idea how to do it on the blockchain itself, but I wish there was two-factor authentication in some form or another. And I know people want to do it with smart contracts and things, and maybe that's the only way you can really do it. I mean, the blockchain, both Ethereum is basically just code executing all the time, right? It's all just execution of programs at the end of the day. So you need some form of two-factor authentication. If not, your banks have to do it. You ever wake up in the morning and worry that when you log into your bank, all your money was stolen? Like you never worry about that, right? I never have my MetaMask, my little, even though it's got maybe $5 in it, I never turn that thing on in my browser, dude. I'm like, dude, Bill, you got $10 in there. I don't care. I just don't want it stolen. I don't know what's going on. And I'm like a software developer and I'm panicked, you know? But I think I want the tech to continue to be built. I think systems like Tendermint, which is like, so you can have your own private Cosmos, DB and Tendermint are really cool projects. And I want this technology to continue to be built and improved. I don't think it's a solution looking for a problem to solve. I think there's some really valuable stuff with the tech. I just think it's being misused today. And I think a lot of people are getting hurt today, and that's really a shame. But I've tried to separate myself from all of that with the tech, right? I'm not doing NFTs. I'm not speculating. I'm not doing any of that. I'm not even promoting it. I'm not even, like, none of that. I just want to have a strong foundation. And I think if you're looking for advanced topics for any programming language you're working on, try to build some of this stuff. Like, you'll sharpen your skills really trying to build any of this stuff. And so I think there's value in some of that too. At least that's what I'm trying to teach there. So when people come to my blockchain class, like, you're not going to leave suddenly being able to start building distributed apps, because that's the quite opposite of where I'm at. What you're going to leave with is you'll be probably the smartest person in the room the next time they're talking blockchain, but you'll have a good visual understanding of how to build something that complex and at least how to do it in Go, which could apply to anything else you're doing later on in engineering when the complexity you have to deal with gets to that point. I mean, anything in distributed, decentralized, consensus, raft, these are real. That, and to me, calendar. Calendar is complex. I don't know why. Try to build a calendar app, man. Scheduling and calendar is about as complex as blockchain in my head. I don't.
So a side database. I like the whole idea of how you describe it. It really simplifies it, I think, for the listeners as well. Now, one thing. So Go is in, right? We noticed. We're a marketplace. We're primarily focused on tech. Go is super high demand, super low supply. Now, one question I have for you, and probably relevant for our listeners: when to go and when not to go?
I think, God, that it's a tough question, because I think there are two programming languages you have to consider today. Outside of, look, if you're a Java shop and you're really successful and you got a very large code base and you're not doing anything new, and that's where you're like, stay in Java. I have no problems with all the programming languages that are where you're productive, okay? But if you're having problems with the systems that you're working on today, or you're looking to do new development and you want to experiment with new stuff that's out there from a programming language, right? I think there's two of them out there you have to look at and seriously look at. Well, I think one is Go and the other one is Rust. Now, the question becomes for me, when would you choose maybe Go over Rust? One, I would always say prototype the basics of what you're doing in both and get a feel for that. But for me, this is kind of the way I look at it. If you're building a system where you have to remove latency out of the equation because performance is just that critical, usually these are systems that are doing high-end kind of in-process. Forget about like networking stuff for a second, like a browser, maybe an operating system, where you really have to remove as much latency, if not all of it, from the internal algorithms that you're building. Then Rust is going to be your programming language, because Rust is about, right, really having, say, no garbage collection in your way. It's not about having latency working around your solution. It's about removing it completely. But if you're building services that are sitting on networks, talking to other services, then your biggest performance problem isn't internal algorithm performance. It's waiting the half a millisecond or more on a response to come back. So this is where Go shines. I think Go is from a programming language syntax going to be more familiar to you if you worked with any other curly brace language. So you get up and running quicker because you already kind of have a good strong foundation for the syntax, even if you're new to it. But I call Go a programming language where it just has to be fast enough and you can get latency to work for you, not against you. This is where concurrency comes in and all the multi-threaded programming, right? Like if you're waiting on if this thread's waiting on the network, we bring another thread in to do some other work. And if that starts waiting, we bring another thread in. Where there's latency, but it's not necessarily hurting you. We're making it work for us because we can do a lot of other things, right? Where sometimes you have something that's truly going to be single-threaded. That latency is death. And I think you have to kind of really be honest about the performance, right? If performance truly is your highest priority, which I think a lot of people miss here, then I think you really want to look at Rust. Again, reducing latency or removing it. But if you're going to be sitting on the network, then learn Go and learn how to really write good concurrent multi-threaded software. And don't, I say this all the time, don't add complexity until you need it. Just don't do it. You know how many times I walk into a shop and there's like 4 people and they're already written like 6 microservices and they're failing because the complexity and just these microservices talking to each other and all the distributed logging. And I'm like, you know how hard it is to build one service and it just works every single day, day in and day out? You know how hard that is? And you wanted to start your project off already with like 4 of these? Like, why did you add that? Oh, Bill, we need the scale. You don't need the scale just yet. Plus, money can solve a lot of problems. If you build your monolith in a way that you can go behind a load balancer, you can live for 6 months. Yeah, it might cost you a little bit more money, but at least you're running. You can learn from that. Then you can decide, do we need that sidecar or do we need a way of doing this or that, right? And so it's whether you're writing the software internally or not, it's don't add complexity until you absolutely know you need it, until there's some measurement, wherever that measurement is, that's saying that this solution is no longer working for us. Now we add the complexity to it. And make sure you have the right people around you that can deal with that complexity. Or boom, you just fall down, right? And we go back to the legacy hards again. So I think Go is going to get you up and running quicker in terms of language syntax and use. The Rust syntax is a little different. I've heard that if you're a Ruby developer, I played a little bit with Rust, right? Like the syntax is foreign to me. This is going to take time. But I heard if you're a Ruby developer, it feels more natural to you than say if you have like my background, which was more of a C background. But most of us today are building product that sits on networks, that's sending and receiving messages over a network. And I think if you think about Google for a second, like what is Google's entire business model, right? It's search and download and everything else, right? And so the language that they've invested in isn't Rust. They invested in a programming language that will allow them to. Now, nobody's replacing the C legacy code for search over at Google, right? But there's a lot of other stuff they're building now in Go, which is giving them that performance they need without all that complexity. And when you think about who funded Rust, that was Mozilla, right? With that first project being a browser, it makes total sense. I wouldn't really try to write a browser in Go. Like the rendering engine has to really perform. You don't want a GC in the middle of that. At least I don't think you do. So when you think about Mozilla and Rust, and then you think about Google and Go, and start thinking about what they're building and what Google's building, I think that gives you a pretty good kind of line in the sand on, am I kind of on the Mozilla side of what we're building? Am I in the more of the Go side? Or maybe I've seen some projects where I'm kind of on the Go side, but there's such heavy duty internal processing that goes on that I still need the extra reduction in latency costs. That there's just no way around it, right? And that you really better make sure that's true when you make that decision. So I heard this. I heard there's all the cell towers now are basically running software that runs on Kubernetes right there at the cell tower, right? So Kubernetes is helping to orchestrate all of that. Now, there's communication going on in these services, but there you really have to reduce latency. There's just no way around it, right? You get too many phone calls coming in, too much data packaging, all that stuff. Their internal latency kills. So that's a perfect project for Rust, where you're still on a network and you're still moving data, let's say. But, right, you don't want a GC cycle in the middle of your call. Let's just say that. So you just have to be smart. But I think at a high level, you can kind of think of those two solutions and fall into one of those buckets.
Wow, spoken like an experienced instructor. I love how you talk about it, Bill, because yeah, for somebody, I mean, both of you are technical, but for somebody who's not as technical as I am, I feel your passion, and I understand. I understand, through you the complexities of all this software, even if it's so popular, even if it's the hype these days. There's a lot of complexity behind it, and it's great to hear from an expert like yourself what your thoughts are on the subject. And for students or people who would be interested in learning more, how best can they find you? You talk about your blog earlier and your classes. How can they best find you or reach you?
So when I was writing my blog post for the first time, I knew zero about social media. Knew zero about. In fact, I asked people, "Is there a book about Twitter? Because I don't know how to interact on this." And everybody said no. So my brain said at the time, "Well, I'm going to keep my private life private, and I want a Twitter account that's just for work, right?" So I had gotten the domain goinggo.net for my blog. So what handle should I use for Twitter? So I took goinggo, DOT.net, not knowing anything about social media or nothing, goinggo.net. So that's my Twitter handle. And I've not changed it because now over the years, everybody knows me as goinggo.net. The website, the domain will take you to the Ardan Labs, ARDAN, Ardan Labs website where the blog is now living. So I've kept the domain. And I've learned that you have to intermix a bit of your personal life or you're just a cold robot at the end of the day on social media. I should just write a book. There needs to be a book for anybody to learn how to handle Twitter, just even Twitter. That's the only one I deal with correctly. So goinggo, DOT.net, goinggo.net, that's where the handle comes from, the original blog website. DM me there. Bill at ardanlabs.com. Love email. And then you can go to the Ardan Labs website for the blog and reach out. I'll get back to everybody within 24 hours, if not sooner. I really believe that if somebody reaches out to you, asks you for help, you should be saying yes, unless obviously, for whatever reason you can't. Like I was just telling this to the 15-year-old. She kept saying no to me this week. Like every time I asked her something,
number 5 or number 4?
This is number 6. So number 6. Okay. So I finally said, number 6, you know what? We're going to watch Yes Man. So I made her watch the Jim Carrey movie, Yes Man, like 2 days ago. And then I told her the next day at school, you are going to say yes at least 5 times today to something. And she actually did it. She actually said yes a couple of times to something she normally would have said no to, right? I'm trying to get her to do that. So if you come and you reach out to me and you ask a question, a technical question, I'm going to do my best. If I don't have an answer, I'll get somebody to answer. But I'm not going to say no unless it's really something immoral, unethical, or just something I can't do. And that is.
Fantastic. Well, Bill, thank you. Thank you so much for being a guest in today's episode. I have learned a lot, and I'm sure our listeners have learned a lot, and Wouter as well. And thank you for sharing all of your wisdom and experiences today. We hope we get to meet again and talk some more in the future. And, once again, this is Jacqueline de Monk.
And Wouter Del Bare.
Thanks again,
and Bill Kennedy.
Yes, here. Stay tuned for the next episode of Mangtas Nation.
Thank you for tuning in to Mangtas Nation. Mangtas, your curated marketplace for B2B outsourcing solutions. Follow our social media pages to know more about us. Sign up as a client or sign up as a vendor and be part of this global B2B marketplace. Join us at www.mangtas.com.